Hello students, let's start our next lesson. Let's recall which are the gases present in air. Why is air called a homogeneous mixture? The answer: gases like nitrogen, oxygen, carbon dioxide, 6 types of inert gases, nitrogen dioxide, sulfur dioxide, etc., are present in the air. Air is a mixture of all of these gases. The constituent gases cannot be separated naturally from these mixtures. Therefore, it is called a homogeneous mixture. What are the uses of the various gases in air? Answer: nitrogen helps in synthesis of proteins. It also helps in production of ammonia and in airtight packaging of the foodstuffs. Oxygen is essential for combustion, that is burning, and respiration. Carbon dioxide is necessary for photosynthesis and is also used in fire extinguisher. Different inert gases have specific use for each of them. Properties of air. Air is all around us. We cannot see it, yet we feel the presence of air. When we inhale, air is taken in through the nose. If we blow on our hand through our lips, we can feel the air.
Take a stick from a broom, or paper or plastic, 2 balloons, sellotape if required, rubber, and a pin. See that you have to hang that broomstick, so you have to adjust the center. At the center you can tie thread or here rubber is used. You have to hang it to rigid support. Now you can see the broomstick is horizontal. Now you are going to tie balloons to both the ends of this broomstick. You can use sellotape to fix it there. Here the broomstick is still horizontal. Now with the help of a pin, we are going to inflate one of the balloon. There is a pin. Let's prick it. The stick goes down on the side of the inflated balloon. This means that air has weight. Air is a mixture of gases and therefore, like all other matter, it has mass and weight. Take an injection syringe without the needle. Pull its piston and observe it as you do so. The piston can be pulled out easily. The piston then remains in that position even if you let it go. Now, close the inlet hole of the syringe tightly with your thumb. Pull the piston and let it go. Is the force required to pull out the piston more or less than before? Does the piston remains as it is after you let it go? The molecules of gases in air are in constant motion. When these molecules strike a body, they create pressure on that body. This is the pressure of air that we call atmospheric pressure. On pulling the piston with the inlet hole of the syringe closed, more space becomes available to the air in the syringe and it becomes rarefied. As a result, the pressure of the air in the syringe is lowered. Comparatively, the pressure of the outside air is very high. That is why When the pulled out piston is released, it is immediately pushed in. If this experiment is repeated, holding the syringe in different positions like vertical, horizontal or inclined, the piston is found to go into the same extent in all the cases. From this, we can infer that atmospheric pressure is the same in all the directions. Do you know? Under ordinary conditions, atmospheric pressure at sea level is about 1,01,400 newtons per square meter. It can be measured with the help of a barometer. As we go higher above sea level, atmospheric pressure decreases. A little fun. Place a piece of cardboard on the mouth of a glass filled completely with water. Holding the cardboard firmly in place with one hand, invert the glass quickly. Take your hand away from the cardboard. What do you see? Great scientist. In 1726, the Swedish scientist Daniel Bernoulli put forth the important principle that the pressure of air decreases when its velocity increases, while the pressure of air increases when its velocity decreases. If a body is moving through air, the air pressure decreases perpendicular to the direction of the motion, and then the air in its surroundings flows rapidly from higher pressure to the lower pressure. Observe and discuss. Take some water in a glass. You can use any other container too. Fill the glass with water. After that, we are going to add little ink inside so that the water is going to become blue in color. You can use any other color too. Here syringe is used to remove ink from the bottle. You can use any other convenient method to remove ink or any other color. Water is becoming blue. Now take 2 straws. Here we have used empty pen cases. Hold a straw upright in it. Hold a small piece of another straw near the upper end of first straw and perpendicular to that straw. Blow hard through the small piece of straw. You will see a fountain of water. Why did this happen? On blowing through the straw, the air at its open end is pushed away and hence the pressure of the air at the opening goes down. As the pressure of the air near the upper end of the erect straw becomes less than atmospheric pressure, the water in the glass is pushed from where the pressure is higher to where it is lower. That is, in the upward direction, and the water comes out in the form of a fountain. The more forcefully you blow, the higher will be the fountain. This straw fountain works on Bernoulli's principle. Use your brain power. What is the effect of increased temperature on the pressure of air? When the temperature increases, the pressure of air also increases. For example, as the air warms up, the molecules in the air become more active. They use up more individual space even though there is the same number of molecules. This causes an increase in the air pressure. When there exists a difference in the air pressure at two different places, the air starts flowing from the place of higher pressure to the place of lower pressure. At such times, we feel a breeze or a wind blowing. Thus, winds are an effect of the difference in air pressure. Try these. Take ice cubes in a glass up to 3/4 of its height. Now observe what happens. How did the water droplets appear on the outside of the glass? Due to the ice cubes in the glass, the air surrounding the glass cools down. As the water vapor in this air cools down, it condenses and gets transformed into water. It is water that collects on the outer surface of the glass. The level of humidity is different in different places. Similarly, the humidity levels also change from time to time during the period of a single day. The level of humidity of the air is determined by its capacity to hold water vapor. During the night or at dawn, when the temperature of air is low, its capacity to hold the vapor is less. At such times, the excess vapor is transformed into water droplets. This is what we call dew. In the afternoon, when the temperature of air is high, the capacity of the air to hold the moisture also increases. Then compared to its full capacity to hold water, the proportion of moisture in the air is less and we feel that the air is dry. In summer, wet clothes dry quickly, but in the rains, they do not. Why is this so? The air during rainy season is humid. The air contains much moisture during this period. The wet clothes dry only when the moisture in these clothes evaporates into the atmosphere. But due to excessive moisture in the air during rainy season, moisture from wet clothes is not lost. Therefore, the clothes do not dry up soon. On the other hand, during summer season, the temperature is high and humidity is less. The clothes therefore dry quickly in summer. Use your brain power. Dip an uncorked inverted empty bottle in a slanting position into the water in a wide container. What do you observe? When an uncorked inverted empty bottle is kept slant in the water container, bubbling sound will be heard. Air bubbles come out from the empty bottle and water goes inside the bottle. Empty bottle is actually not empty, but it is occupied by air. When this air comes out, its place is taken by water. It shows that air occupies space. What change takes place in a balloon on filling air in it? On filling air in balloon, the shape of the balloon changes. Its size increases due to expansion. We come to know from the activities above that air has properties like occupying space, having a certain volume, having mass and weight. Air is a mixture of very fine particles of some gases, dust, smoke and moisture. When rays of light fall on these minute particles, the particles spread the light in all the directions. This natural phenomena is called scattering of light. Temperature regulation. The earth receives energy from the sun. This energy is reflected by the earth in the form of heat. The constituents of air surrounding the earth, such as water vapor, carbon dioxide, absorb a part of this heat and give it to the other constituents of air. As a result, the earth's surface remains warm and thereby becomes suitable for the living world on the earth. If there were no air on the earth, the average temperature of the earth's surface would have been very low. Transmission of sound. All the sounds that we hear reach us through the surrounding air. The density of air also changes due to change in its temperature. In winter, the density of the air increases. We can hear the whistle of a distant train clearly early in the morning in winter. Air is useful as a medium for the transmission of sound.